Okay, we are back and we are still talking about slope. This time we're going to look at how we can use 2 points on a line to find slope. So we have here 4 points, and we're first going to look at the line that would connect all of these. So I'm going to look at drawing a line somewhat through all the points as close as possible, indicating that it goes on forever and ever. And then we're going to look at the slope at these different pieces. So we're first going to look at L to N. So what we've done in the past is we would calculate the rise by just counting the number of steps up to get the rise, and then counting the number of steps over to get the run. And we would just use our grid lines to do that. But sometimes you'll just be given points, and you have to use those values to figure out the slope. So what I'm really doing when I'm finding the rise values is finding the change in y. So when I look at these 2 ordered pairs, I have 2, 3, and 0, 2. And to find the change, I'm going to subtract my y values. So I'm going to do 3 minus 2. And I would find the difference or the change between those 2 values. And I would get 1. Then when I'm finding the run, what I'm really looking for is the change in my x values. So once again, I'm looking at my x values this time, 2 and 0. And to find the change, when I go from 0 to 2, I'm going to find the difference between those 2. So 2 minus 0, giving me 2. Well, now I have my rise over my run from those 2 points. We just confirmed it with the grid lines, but I found my rise over my run or my slope to be 1/2 using those coordinates. And if you notice, you see them here. I have 3, 2, and 2, 0. So now let's look at M to N. And I'm just going to switch the colors up here so it's a little easier to see. But yet again, we're finding the change in y first. So I'm looking at 2, 3, and 8, 6. If I want to find the change in my y values, I'm really looking at 3 and 6, right? Because those are my y values. And if I want to find the difference between those 2, that's how I find the change in those values. So I'm going to do 6 minus 3. And when I subtract those 2, I find my rise to be 3 units. Then when I look at my run, what I'm really looking for is the change in the x values. So yet again, I look at 2, and this time I'm going to look at 8 with that 2 to figure out how our x value shifts when we move along this line. So to find the difference, I do 8 minus 2, which would give me 6. And then when I simplify that, I end up with, yet again, 1/2 for my slope of that portion of the line. So what we are doing mathematically is we are taking those 2 ordered pairs and we are saying, okay, I'm going to subtract my 2 y values. So in our second example with M and N, I'm going to take my 6 and my 3 and subtract those to get my rise value, which is 3. And then I'm going to look at my run by taking my second x value, 8, and subtracting the first one, 2, to give me 6. And then I simplify that slope to get my m value. If that is confusing, that is okay. We're going to kind of take this graph away and just look at ordered pairs and see how we can figure this out. So go ahead and make sure you have this written down, and then flip your notes over to these 4 guided practice problems. And what we're going to do is find the slope using this equation right here. We're going to plug our x and y values into that equation. So for number 1, it says find the slope of the line that contains the points 2, 5, and 9, 3. So the first thing I'm going to do is label these. So 2 is going to be x1, 5 is going to be y1, 9 x2, 3 y2. So that's just letting me know 2, 5 is my first point, 9, 3 is my second. The order of those does not matter. You could make 2, 5 your second point and 9, 3 your first. Either way, you will get the same slope. And what I'm going to do once I've labeled those is write down y2 minus y1 over x2 minus x1 equals, and then I'm going to plug in those values for those variables. So my y2 was 3. So I do 3 minus y1, which is 5, over x2, which is 9, minus x1, which is 2. Then I subtract those, and I get negative 2 over 7. And I can't divide that into a pretty number, so that would be my slope. I would have my m value equal to negative 2/7. For example 2, we're going to do the same thing. So 5 would be x1, 1 would be y1, negative 8 x2, and positive 1 y2. And then I use this kind of formula to find my slope. So I'm going to do 1 minus 5 over negative 8 minus 5. Oh, made a mistake there. That should be a 1. When I subtract those, I'm going to get 0 over negative 13. When I divide 0 by any number, I get 0, so this line would have a 0 slope. For 3 and 4, if you want to try them on your own and then check with this video, I'll go ahead and pause here for a second so you can pause the video. Okay, for those of you that maybe finished the question and you're checking, or those of you still just following along with me, let's do these together. So 3 is x1, 10 is y1, negative 2 x2, negative 4 y2. I use y2 minus y1 over x2 minus x1. And then I'm going to plug in those values. So I get negative 4 minus 10 over negative 2 minus 3. And I end up with negative 14 over negative 5. When you have a negative over a negative, remember your integer rules. That means our slope would end up being positive 14/5 because a negative divided by a negative is a positive. So our slope would be a positive 14/5. For 4, I have x1, y1, x2, y2. We're using y2 minus y1 over x2 minus x1, which for this specific problem is going to be 5 minus negative 2 over 9 minus 9, giving us positive 7 over 0. Anytime 0 is our run value, we know that our slope is going to be undefined because we cannot divide a value by 0. So our slope is undefined, and that is how we use this formula to find the slope when we are only given 2 points on the line and no graph. We'll do